Part 4. So now that we've learned how to work with some powers and what they mean, we're going to do some story problems about it. Okay? So the first thing we're going to do is we're going to do area and volume. So first, how do we find area and how do we find volume? The formula for area is length times width. For these problems, I like to draw a picture, that way I can see what I'm working with. So it says find the area of a square. So here's my square, with side length 14 meters. So what do I know about a square? Well, I know all sides are the same. So if this side's 14, oops, that didn't work very well at all. Let's try that again. If this side is 14, then I know the top is 14. Same with the other side and the bottom. Okay, square, all sides are the same. But for this, all we need is length and width. So I'm just going to keep these two up here on there. So, area equals length times width. What's the length? 14. Okay. What's the width? 14. Okay, so we're going to plug in our numbers. Area equals, length is 14, width is also 14. So 14 times 14 is going to be 196. Okay. It's meters squared. Okay. Area is always squared. Okay. See how we had two 14s. What does two 14s mean? It means 14 squared. So for area, we're always going to have our label squared. Meters squared, inches squared, feet squared. Whatever it is, area is always squared. Okay. Let's do number 20. So same thing, we want to find the area of a square. Here's my square. The side length is 2.5 feet. So I know that each one, all sides, are 2.5. Area is length times width. So my length is 2.5, my width is 2.5. I plug in my formula. L is 2.5, and my width is 2.5. I put these in parentheses just because I have decimal points and I didn't want my middle dot to look like a decimal point also. So when I take that, multiply that together, 2.5 times 2.5 is 6.25. Again, my label is feet squared. Area is always squared. Problem tells me feet, so I write feet squared. Okay, let's do a volume. Alright, so volume of a cube. Here's my picture of a cube. Not very pretty, but it'll work. Okay. So what do I know about a cube? In a cube, all sides are the same. So in my problem it says 2.1 inches. So every side is 2.1 inches. Where to put that? Here maybe. Okay, so length is 2.1, the height is 2.1, the width is 2.1. So our formula for volume is length times width times height. And in a cube, we know that they're all the same. So for our problem here, we're going to say volume equals, my length is 2.1, my width is 2.1, and my height is 2.1. So here, when we multiply that together, I get 9.261. Our label is inches. So here we're going to do inches cubed. A volume is always cubed. Okay? Again, because we have three things that are multiplying together here. Those three things, 2.1 times 2.1 times 2.1 would give me 2.1 cubed, or 2.1 to the third power. So here, my label is always going to be cubed. Let's try a couple more here real quick. So, find the volume of a cube with length 6 centimeters. So I'm going to draw another cube here. Again, our pictures don't have to be pretty, it's just to help us look. So each side is 6. My length, my width, my height. We fill in our formula like we did earlier. Volume equals my length is 6, my width is 6, and my height is 6. When I take 6 times 6 times 6, I get 216. Our label here is centimeters cubed. Centimeters cubed because we're dealing with volume, and volume is always cubed. Our last problem here has a table that it wants us to fill out. So it says, school has been canceled for the next day due to a snowstorm. You call and tell 3 friends the news. Then each of your 3 friends is going to call 3 of their friends. To complete the table. Then it wants us to know how many calls have been made after stage 8. So what it's wanting us to do is it wants us to look for a pattern. So when I look here in my middle column, I'm going to look for a pattern. So I see 2 to the first, or 3 to the first, then 3 to the second. So I'm seeing that my base both times is 3. So I'm going to assume that my bases are going to all be 3 down here also. Then I'm going to look at my exponents. My first exponent is 1, my second one is 2. If I follow the pattern, I'm going to have an exponent of 3, 4, and 5. Okay? So where did they get 3 from? Well, they evaluated 3 to the first power. 3 to the first power is 3. I know that 3 squared is 9. So now I just need to finish the pattern. 3 to the third power is 27. 3 to the fourth power, 81. 3 to the fifth power, 243. Okay, so there is completing the table. To complete the table, I found the pattern, and I continue the pattern. So the next question says, how many calls have been made after stage 8? Well, if I look at my table, I don't even have an 8 to deal with. So let's make another one that I can put my 8 in. Okay, so we got 8 down here. So the question is, I can't continue the pattern because I skipped from 5 to 8. But when I look, my exponent for stage 1 is 1. My exponent for stage 2 is 2. My exponent for stage 3 is 3. My exponent for stage 4 is 4. And my exponent for stage 5 is stage 5. So if I continue that pattern, I'm going to keep my base the same because it's always been the same. And I'm going to carry my 8 over as the exponent. Then continuing the pattern over here, I need to figure out what 3 to the 8th power is. I would use a calculator here. Remember, we can go 3 caret 8. And when I do that, I get 6,561. So how many calls have I made after stage 8? 6,561. Okay. Notice as I'm going down, my numbers are getting big, and they're getting big fast. Okay, that's what exponents do. Okay. So at this point, we are finished, and you need to go and do 1.2, checkpoint 4.